When a disaster happens, it becomes news around the globe. Whether it's the scale or the spectacle.
Look at the debris. Look at all the debris. Look at all the debris in the air.
The financial cost or the lives lost. These massive events fill mankind with fascination and fear. In this series, we're looking at some of the biggest disasters to ever strike the planet.
Mounds of twisted steel and cables mark a spot over a river in Vietnam where a bridge under construction has collapsed.
For the next hour, we'll see some of mankind's greatest engineering achievements fall prey to accidents, negligence, and design flaws. In better times, they carry us safely over rivers and valleys or under cities and mountains. But when things go wrong, they can become deadly to anyone using them. Take great care and watch the path ahead, because today, we're looking at the top 10 bridge and tunnel disasters. Over the millennia, humans have demonstrated a spectacular genius for building. We've erected pyramids, cathedrals, towers, and have met increasingly technical challenges to build monuments that defined each era. And among the most spectacular constructions, two moved us further along than any other: bridges and tunnels. Building a bridge over the void, or digging a tunnel under millions of tons of rock, requires a high level of technological prowess to achieve a result that's both efficient and safe. But unfortunately, even with the greatest advances, risk can't be completely factored out. And history has proven that, under just the right or wrong conditions, these masterpieces of engineering can become state-of-the-art death traps. To select the 10 worst ever bridge and tunnel disasters, we've studied the human and financial toll of accidents that took place around the world since the 19th century. We start our countdown with the event that occupies the 10th place in our ranking. Suspension bridges are among the most spectacular structures in the world. Some, like San Francisco's Golden Gate, have even become symbols of an entire city. But another one of these constructions marked history in a more dramatic way. Let's head to the city of Tacoma, Washington in the US, where a suspension bridge collapsed just months after its debut.
Opening of the new $6.5 million Tacoma Narrows Bridge over Puget Sound.
July 1st, 1940, the Tacoma Narrows Bridge opens with great fanfare. 1,810 meters long, the bridge connects the city of Tacoma to the city of Gig Harbor, located on the Olympic Peninsula. It crosses an arm of the sea known as Puget Sound. Construction took 1 year. The principle of suspension bridges is to support the load of the bridge deck by cables, which are secured at both ends. For the design of the Tacoma Narrows Bridge, the engineers relied on a technique called elastic distribution. In principle, in the event of strong winds, the suspension rods are supposed to distribute the load evenly over an entire structure. But instead of stiffening the deck with beams 7.6 meters thick, the Tacoma Narrows engineers chose beams 2.5 meters thick. It cut costs and gave the bridge a finer, more majestic profile. But on November 7th, 1940, barely 4 months after its commissioning, and during gusts of 65 kilometers per hour wind, the bridge begins to oscillate. The deck starts to twist, little by little at first, and then gradually gaining amplitude. Despite its 15,000 tons of steel and concrete, the Tacoma Bridge gets tossed around by the wind like a child's toy. Bridge workers had suspected the inherent flaws of the bridge during its construction. They even nicknamed it Galloping Gertie, because at the slightest gust of wind, they felt like they were on a galloping horse. A University of Washington engineering professor, Frederick Farquharson, had been tasked with finding a solution to the bridge's annoying tendency to wobble. But he didn't get a chance to complete his assignment before that fateful day in November 1940, when the bridge and his work abruptly ended. He can be seen in the distance. In an act of bravery, he's trying to rescue a dog stuck in the car. But the terrified animal won't let him approach, and Farquharson, fearing for his own safety, has no choice but to abandon the bridge and the dog. As it happens, on that day, 2 amateur cameramen from the region, Barney Elliott and Harbeen Monroe, are on the scene with their 16mm cameras. They managed to capture these images, some of the most spectacular in the history of civil engineering. The bridge snaps, and a large part of it crashes into the water, 60 meters below. Luckily, the bridge had been evacuated before it collapsed. Only Tubby, the dog stuck in the car, perishes in the accident.
500 feet above Puget Sound, Washington, they're building a new bridge over the Tacoma Narrows.
10 years later, in 1950, a new bridge was built to replace the notoriously failed and famous Tacoma Narrows. But this time, engineers used much more robust materials and factored in the effects of the pummeling winds. In 2007, the structure is joined by a second suspension bridge to cope with the increase in traffic. Tacoma hasn't suffered any more bridge catastrophes like the one on November 7, 1940. But in some sense, even that bridge still survives in these unforgettable images of the 15,000-ton bridge, twisting in the wind like a rubber band. Whatever its design, a bridge requires regular monitoring to detect any deterioration as early as possible. The stakes are high, so diligent maintenance is imperative. Putting it off means putting lives at risk. And yet, so many structurally deficient bridges remain unrepaired. That's the case with the bridge that takes the 9th place in our ranking. It happened in the heart of Minneapolis, the state capital of Minnesota in the United States, in 2007. The huge Mississippi River runs 3,780 kilometers and crosses the center of the country from north to south. Among the 130 bridges that span it, one has a particularly tragic history. The Interstate 35 motorway bridge. Opened in 1967, it linked the vibrant cities of Minneapolis and St. Paul, serving 141,000 vehicles a day. As a continuous truss bridge, every part of its structure depended on every other part to keep its integrity. Continuous truss bridges are common, strong, and uniquely vulnerable if not maintained. This 8-lane bridge, known as Bridge 9340, was rated structurally deficient in 1990. In 2001, some of the girders were cracking. In 2005, engineers recommended replacing it. But on August 1, 2007, at 6:05 p.m., a portion of the 160-meter bridge suddenly collapses during rush hour. The images captured by a surveillance camera shock the world. 111 vehicles fall 35 meters. Some find themselves stuck in the rubble of concrete and steel. Others sink directly into the waters in the Mississippi. Rescue teams, on site in just 6 minutes, managed to free all the survivors from their cars and take the seriously injured to the hospital just before nightfall. A real triumph. But between the currents and the rubble of the destroyed bridge, finding the victims who fell into the river is the greatest challenge.
3 days later, the weight and the pain are agonizing. Dozens of relatives of those killed in the Wednesday bridge collapse and those still missing received a private tour of the site, getting a look at the mangled remains and grieving together.
The divers spent 3 weeks trying to recover the vehicles swept away after the collapse of the bridge and finding the bodies of all the victims. The final count is 13 dead and 145 injured. The tragedy could have been much worse. It also could have been prevented if the damning reports from the inspections were acted upon a few years earlier. Engineers had originally anticipated needing to replace the bridge in 2020, only it didn't even last that long. An inspection after the collapse revealed why. Analysis of the wreckage exposed a design flaw. Plates used to connect girders to the truss were too thin. One buckled, failed, and triggered a domino effect on the others. The damage tore along a rivet line, leading to a total collapse.
Workers setting concrete, welding, hoisting sections into place. And amid painstaking labor, the new I-35 bridge takes shape.
Barely a year later, the city will inaugurate the St. Anthony Falls Bridge, built in record time at the same location as the old structure. A completely different design, this new concrete bridge was equipped with 323 sensors to detect the slightest vibrations in real time. Since then, Minneapolis residents have continued to confidently cross the Mississippi every day with a thought for those who lost their lives in the Interstate 35 bridge disaster. Among all the types of bridges, the so-called cable-stayed bridges are among the world's most widespread. In these bridges, huge oblique cables called stays are connected to pylons distributed over the entire length of the structure and are anchored to the deck to support the load evenly. The disaster that takes the 8th place in the ranking concerns an early version of one of these bridges. It happened in Italy in 2008, in the city of Genoa. In this port city of more than 500,000 people, a huge bridge was built in the early 1960s and inaugurated on September 4th, 1967. The Polcevera Viaduct, better known as the Morandi Bridge, named after its designer, Riccardo Morandi. Located on the A10 motorway that connects Italy to France, the bridge was a major transport axis. Spanning 1,182 meters, it linked the city center to the industrial port by passing over the Polcevera River, the railway network of the freight station, several industrial sites, and a residential area. The structure was composed of 2 distinct parts. The first, 484 meters long, rested on V-shaped piers very closely spaced from each other. The second, 618 meters long, whose span exceeded 200 meters in length, had 3 90-meter-high pylons from which cable stays could support the load. But on the morning of August 14, 2018, a 210-meter section of the busy Morandi Bridge collapses with no warning. About 40 vehicles plummet into the river and valley by the fall of the deck, killing most of their occupants instantly. Fortunately, traffic is light because it's a public holiday. rescuers extract 16 survivors from the rubble, but the disaster claims 43 lives. 4 days later, Italy honors the victims with a national funeral in Genoa. But half of the victims' families refused to participate. They laid the blame for this senseless tragedy completely on the Italian government. They cite decades of problems with the bridge and a history of negligence almost since its opening in 1967. Throughout the 1970s, the bridge underwent continual maintenance to repair cracks in the overstressed concrete. Moisture penetration through the cracks hastened corrosion of the metal surfaces. In the 1990s, inspections revealed that corrosion had also severely damaged the piers and stay cables. The bridge could support only half its intended load. The government tried reinforcement, but it was not enough. And in 2016, the Italian transport minister was alerted several times that the bridge needed urgent repairs. In 2017, an inspection revealed that the stay cables of Pier Number 9 had reached a critical level of corrosion, to the point of failure. Companies were invited to bid on the repair work, but it was too late. On August 14, 2018, the failure of Pier Number 9 triggered a catastrophic torsion of the deck that triggered the collapse of part of the Morandi Bridge. For almost a year, the broken skeleton of the bridge stood as a witness and grim memorial to the tragedy that claimed 43 lives. By June 2019, a new bridge was planned, and the remains of the ill-fated Morandi Bridge were demolished with explosives. In 7 seconds, approximately 4,500 tons of concrete and steel from the two huge cable-stayed piles number 10 and 11 collapsed in a cloud of dust. A year later, a new bridge of 1,067 meters was born. Designed by Renzo Piano, the famous architect from Genoa, the work is a symbol of the country's new attitude of increased responsibility to its citizens and its infrastructure. For the victims' families and to all the Italian people, it stands as a promise that an avoidable tragedy like the 2017 disaster of the Morandi Bridge will never happen again. Bridges make it possible to span rivers and valleys. Tunnels enable us to pass through mountains. It takes incredible feats of engineering to grind a channel through solid ancient rock. And no tunnel is truly complete until it meets a major challenge, assuring the safety of vehicles that use it. Despite best intentions, things can go wrong, bringing us to number 7 on our countdown. We'll now head to the Alpine Mountains, on the border between France and Italy, where a terrible fire broke out in 1999 in the Mont Blanc tunnel. Towering 4,808 meters, the roof of Western Europe, Mont Blanc reaches its highest point in France, only a few kilometers from Italy. Traveling between the two countries through the Alps used to mean taking small mountain roads and narrow passes. Many of these winding corridors are closed in winter. A solution was devised after the war: to dig an 11.6-kilometer-long tunnel to directly link Chamonix in France to Courmayeur in Italy. a monumental work whose route passes exactly in line with the Aiguille du Midi, Mont Blanc's legendary summit. The first attempts were dug on the Italian side in 1946, but the work officially started in 1959. It took 6 years to build the structure which would be called the Mont Blanc Tunnel. When it was inaugurated in 1965, it was the longest road tunnel in the world and reduced the journey between France and Italy by nearly 100 kilometers. With more than 100,000 vehicles passing through per month, tunnel traffic is dense. Every day, the tunnel is used by tourists, cross-border workers, and especially heavy trucks transporting goods between the two countries. Inside, everything had been planned so that drivers could cross the 12-kilometer tunnel in complete safety. But unfortunately, there's always room for risk. On March 24, 1999, shortly after 10:45 a.m., a truck driver enters the tunnel on the French side. 4 minutes later, smoke begins to billow from his cabin. At 10:53, after having traveled 6 kilometers, he stops. His truck is on fire. Unable to get close enough with his fire extinguisher, the driver decides to flee. Some motorists manage to pass the truck, others turn around. But the semi-trailers are stuck. The burning truck contains a load of highly flammable margarine, as explosive as a tanker truck. The small fire turns into an inferno. The temperature soars, and thick toxic smoke begins to spread. For the 40 blocked vehicles and most of their drivers, there is no way out.
Côté italien du tunnel, les secours travaillent au ralenti à cause de la chaleur et de la fumée.
The Italian firefighters racing to the scene are forced to abandon their vans just 300 meters from the fire.
Un véhicule équipé d'une caméra thermique tente en ce moment de progresser dans le tunnel.
In less than 5 minutes, all the vehicles located near the burning truck begin to ignite. The smoke, laden with carbon monoxide and cyanide, thickens. Electrical cables melt in the flames. The tunnel is plunged into darkness.
La noirceur des visages éprouvés des pompiers en dit long sur l'intensité de la fumée qui s'est propagée dans le tunnel du Mont Blanc.
At the heart of the blaze, the temperature exceeds 1,000 degrees Celsius, and the cloud of toxic smoke spread to the entrance on the French
Les
side.
pompiers n'ont pas pu approcher le camion en flammes à l'origine de la catastrophe. Il est impossible d'accéder à une zone de 600 mètres envahie par une fumée épaisse.
The fire continues to intensify, and firefighters and emergency services cannot intervene without putting the lives of the rescuers in
Les
danger.
secours redoutent d'y trouver de nouvelles victimes.
The fire will burn for 3 days.
Ce soir, le feu couve toujours. La température atteint plusieurs centaines de degrés. Il est impossible d'approcher à moins de 300 mètres du foyer de l'incendie.
And it will take 5 days for the temperatures inside the tunnel to drop to bearable levels so that the clearing work can begin.
Il se pourrait qu'on ait 1, 2, voire 3 véhicules. Mais c'est vraiment une incertitude.
When the rescuers finally manage to reach the center of the tunnel, they discover an apocalyptic scene. Burnt-out vehicles, charred bodies. 29 people died in their vehicles. 9 others tried to flee on foot, but died of asphyxiation.
Les questions restent nombreuses sur les circonstances de la catastrophe. 2 enquêtes ont été ouvertes ce soir. Une technique administrative sous l'autorité du ministère des Transports, une autre judiciaire par le procureur de la République de Bonneville pour homicide involontaire.
Following this tragedy, new safety measures are put in place in tunnels around the world to alleviate smoke in the event of a fire.
Une centaine de familles a fait le déplacement jusqu'à Bonneville.
During the trial in 2005, 12 people, including the mayor of Chamonix and the head of tunnel security, were found guilty of manslaughter and negligence. They were sentenced to prison terms of 4 to 30 months. The truck driver who escaped unscathed by abandoning his vehicle received a 4-month suspended sentence. It's a sad irony that it takes 39 deaths and a tragedy like the one in the Mont Blanc tunnel to create better safety protocols. But the situation here is not unique. Crossing the Alps has always been a real challenge. Many other road and rail tunnels were drilled through the mountains to more quickly connect France, Italy, Switzerland, and Germany. And the Mont Blanc tunnel is not the only one to have experienced a terrible disaster. To investigate the event that takes 6th place in the ranking, let's head to Switzerland, where another large-scale fire hit the Gotthard Tunnel in 2001. The Gotthard Massif in Switzerland culminates at more than 3,600 meters. Throughout history, its position has made it a highly strategic location. Located on the north-south axis, it has to be crossed to connect the industrial regions of Northern Europe and the ports of Rotterdam and Antwerp to northern Italy and the cities of Milan and Turin, as well as the port of Genoa. In 1969, a road tunnel was built to facilitate European trade. Stretching 17 kilometers, it exceeds the Mont Blanc Tunnel. And when it opened, it was the longest tunnel in the world. With 6 million vehicles per year, including 900,000 heavyweight vehicles, traffic is extremely heavy in both directions. And if a collision occurs inside such a long tunnel, the consequences can be terrible. And that's what happened on October 24th, 2001. At 9:45 a.m., 2 trucks collide about 1.5 kilometers from the south exit. Under the impact, a fuel tank ruptures, spilling a puddle of diesel onto the road. A short-circuiting electric cable causes a spark and triggers a gigantic blaze. One of the 2 trucks is transporting tires. Black, thick, and toxic smoke fills the tunnel. The temperature suddenly soars to hundreds of degrees Celsius. Visibility is reduced to 0, and the air becomes unbreathable. But the Gotthard Tunnel is better designed than the older Mont Blanc Tunnel and equipped with an evacuation gallery. It is accessed by emergency exits placed every 250 meters and runs along the road for its entire length. Ventilation systems also help remove smoke. The next day, when the temperature inside the tunnel had dropped, the emergency services discovered more than 40 charred vehicles, and among them the carcasses of the 2 heavyweight vehicles responsible for the accident. Despite the tunnel's safety features, 11 people are found dead. It could have been much worse if the structure had not been equipped with an emergency gallery and an efficient ventilation system. But in Switzerland, the tragedy will revive the debate on the density of road traffic within the Gotthard Tunnel. To relieve congestion, a 57-kilometer rail tunnel was inaugurated in 2020. Called the Gotthard Base Tunnel, it has become the longest tunnel in the world, and its construction cost more than 20 billion euros. Even more, construction of a second tunnel next to the first has already started. By 2032, each direction of traffic will have its own tunnel to reduce the risk of collision and ensure that the disaster of October 24, 2001 can never happen again. From the beginning of the 21st century, Asia has seen the construction of monumental bridges. China, Taiwan, Malaysia, Thailand. Structures several kilometers long have been built in many countries. One of them, the bridge Kuna, made headlines following a terrible tragedy that occurred during its construction. The disaster takes 5th place in the ranking. It happens in September 2007 in Vietnam, in the city of Kuna, in the south of the country. With a population of 1.2 million, Kuna is the largest city in the Mekong Delta. Its legendary river is the 4th longest in Asia. In 2004, construction began of a 4-lane cable-stayed road bridge designed to cross one of the arms of the Mekong and connect the province of Vĩnh Long to the city of Kuna. The objective, to replace a slow and overcrowded ferry service. The ambitious project was slated to last 4 years and cost over $300 million. But 3 years in, on September 26, 2007, at 8 a.m., a portion of the 87-meter-long access ramp, 30 meters high, collapses while 250 workers are constructing it.
Mounds of twisted steel and cables mark a spot over a river in Vietnam where a bridge under construction has collapsed.
The tragedy is unbearable. For 4 days, rescuers struggled to reach survivors trapped under tons of tangled concrete and steel.
The 4-lane bridge was supposed to be finished in 2008. It would have been the largest suspension bridge in Vietnam.
The magnitude of the collapse made the rescue difficult. In the end, 54 are dead and more than 100 are injured.
Adding, quote, "We still don't know the cause."
The ramp portion was supported by 3 pillars, numbers 13, 14, and 15. One hypothesis for the cause of the accident is that the heavy rains had softened the ground at the construction site and the concrete of the piers were stripped too soon. When the concrete for the deck was poured, it multiplied the load by 3. According to witnesses, pillar number 14 began to tilt, tearing a part of the deck located above pillar number 13. That pillar then tilted and caused the entire formwork to fall. In a domino effect, the entire portion under construction collapsed. Some experts claimed that the builders had been cautioned 8 months before the accident that the pillars could only support 15% of the expected load. But the work continued despite the warning, and no specific measures were taken. This overt negligence led to one of Vietnam's greatest civil engineering disasters to date. Among the types of bridges that have enabled humans to cross rivers, perhaps the most unusual is the floating bridge. Quick to install, floating bridges are often used by military forces when a watercourse blocks advancing troops and vehicles. A bridge that floats seems like a safe bet, but not always. This catastrophe takes the 4th place in our ranking. It happened in the Portuguese city of Porto. The city is famous throughout the world for the 6 bridges that connect the banks of the Douro River between Porto and the Via Nova de Gaia. These bridges include the Arabida Bridge, closest to the mouth of the river, and the Dom Luis Bridge, a symbol of the city and a UNESCO World Heritage Site. But before these bridges, more than 200 years ago, another bridge crossed the Douro and ended in disaster. Back then, Portugal erected a floating bridge called Puente de Barcas, or the Bridge of the Boats, to help the citizens of Porto and their goods circulate between the banks of the river. Designed by the Portuguese engineer and architect Carlos Amarante, the structure consisted of 20 boats connected by steel cables. It could be opened in 2 parts to allow river traffic. It was inaugurated in August 15, 1806. But 3 years later, Napoleon's forces attacked Portugal, triggering the First Battle of Porto. As the soldiers enter the city and begin to evacuate the citizens, shooting those who refuse to obey, the inhabitants have only one option: to flee across the river. Thousands of men, women, and children rush to the Puente de Barcas. The sheer number of people racing uncontrollably across the bridge creates a situation that the engineers could never have imagined when they designed the structure. The bridge simply isn't up to the task. It shakes apart and sinks into the Douro, taking many lives with it. It is estimated that between 4,000 and 6,000 people lost their lives that day, drowned in the raging waters of the Douro while trying to escape the French troops. And it was all for nothing. Barely 1 month later, the city was retaken from Napoleon's hands by Portuguese and British forces. The fall of the Puentes de Barcas isn't just a sad day in Portuguese history, it's also the deadliest bridge accident in the world. To access the snow-capped peaks, skiers can use cable cars, chairlifts, or a less widespread but very efficient system called a funicular. 2 cars, placed on rails, are connected to each other by cables. The cars function like counterweights. The descending car is held by the weight of the ascending one, while the ascending car is partly pulled upwards thanks to the energy generated by the descending car. This reliable system enables you to climb the steepest slopes in complete safety, most of the time. A funicular was the site of one of the deadliest recent disasters. This one takes 3rd place in our ranking. It happened in Austria in 2000, in the small town of Kaprun, located south of Salzburg. Kaprun is a renowned Austrian resort where tourists come to enjoy a spectacular ski area open 11 months of the year. The Kitzsteinhorn Glacier, rising more than 3,200 meters above sea level. To access the slopes, a funicular was inaugurated in 1974, one of the most modern of its time. The 2 trains could scale a 30-degree slope at 25 kilometers per hour, taking 9 minutes to cross the 3,900-meter route, including 3,200 meters inside a tunnel. In the morning of November 11, 2000, 161 passengers board the funicular. In the front cabin, the driver operates the doors. As the train heads uphill, the rear cabin is empty, but an auxiliary electric heater keeps working. And that's where the trouble begins. The device is defective and catches fire. The flames quickly melt the plastic tubing that circulates the funicular's flammable hydraulic fluid. The resulting drop in pressure stops the funicular in its tracks, 600 meters inside the tunnel. The fire then begins spreading through the train, trapping the 161 passengers. At the front, the driver manages to open the doors. To escape the flames, passengers naturally flee towards the summit, a wrong and deadly choice. The tunnel acts like a gigantic chimney, sucking in oxygen from below to feed the fire and pushing toxic fumes upward. Every passenger who runs forward dies of asphyxiation, along with everyone 2.5 kilometers further up in the arrival station. Ironically, only those who ran downhill toward the fire come out alive. The next day, while the firefighters manage to get the fire under control, the rescuers can finally enter the tunnel. They discover a scene of devastation. The death toll is 155. It will take several weeks to identify the bodies of the victims charred by the flames. Only 11 passengers survive. A trial is held, but the Austrian courts release the 16 people accused of negligence. Despite protests from the victims' families, no personal fault could be proven. Since then, the tunnel has been sealed and the funicular rails were destroyed. 4 years after the tragedy of November 11, 2000, a memorial was installed near the site of the disaster in memory of the 155 people who lost their lives. Pedestrian bridges are elegant, popular, and very useful for crossing waterways, railways or highways, and sometimes for linking buildings. The disaster that takes second place in our ranking happened on a footbridge in Kansas City, Missouri in the US in 1981. At the time, the Hyatt Regency was one of the most luxurious hotels in the city. Opened in July 1980, the building was distinguished by the large volume of its lobby, featuring 3 catwalks suspended from the ceiling by steel rods. They connected the north and south wings to the 2nd, 3rd, and 4th floors. Each measured about 37 meters long and weighed nearly 29 tons. The 4th floor walkway was located parallel to the 2nd floor walkway. In July 17, 1981, in the early evening, the dance hall was full as 1,600 people had come to attend a dance festival. 20 people are on the catwalk on the 4th floor, 40 on the 2nd floor walkway. All are watching the event below when suddenly the catwalk on the 4th floor collapses. Smashing onto the one on the 2nd floor. Together, the 2 failed footbridges come crashing down into the crowded hall.
C'était un film d'horreur au ralenti, raconte un témoin. Au bar, je regardais les danseurs du concours au milieu du hall de l'hôtel quand j'ai entendu un craquement sourd. Le temps de lever la tête, une passerelle surchargée de monde s'est effondrée au-dessus de nous et dans sa chute, elle en a entraîné une autre.
Dozens of people die instantly. Hundreds are injured or trapped under the rubble. It will take 14 hours for the rescuers to extricate the survivors from the heaps of concrete, glass, and steel. At final count, 114 are killed, and 216 suffer serious injuries. The investigation showed that the designers had suspended the second-floor walkway by tie rods, 32 millimeters in diameter, from the fourth-floor walkway rather than from the ceiling. That meant the fourth-floor walkway bore the burden of its own weight, the weight of the second-floor walkway, and the weight of all the people crossing the bridge. The structure rested on 3 beams attached by the tie rods, fixed by nuts. The heavy load caused the nuts to sever the weld points. Disaster was inevitable and avoidable. It was said during the trial that even a freshman engineering student could have anticipated the disaster. The victims and their families receive hundreds of millions of dollars in compensation. The gross negligence in the design of the Hyatt Regency Hotel's walkways triggered wide-ranging reforms to safety standards in the United States. The hotel was rebuilt, and the new lobby walkway rests on concrete pillars. The building is considered one of the safest in the country. But the tragedy of July 1981 marked Kansas City and remains today the deadliest accident linked to the structural failure of a building in the history of the United States.
Les pompiers n'ont pas pu approcher le camion en flammes à l'origine de la catastrophe.
Drama in France in the Mont Blanc tunnel in 1999.
Pour parvenir à éteindre l'incendie.
In Kaprun, Austria in 2000. Or in Switzerland in the Gotthard Tunnel in 2001. As we have seen, fires in closed spaces such as tunnels are devastating. And one of them takes first place in our ranking. It happened in 1995 in Azerbaijan, in the country's capital, Baku. Azerbaijan is a former Soviet republic that became independent in 1991. Rich in hydrocarbons, the country is booming, and ultra-modern buildings spring up like mushrooms. Today, the Baku metro has more than 30 kilometers of line and is used by more than 200 million passengers per year. But in the 90s, a terrible disaster struck an old Soviet-era metro train. On October 28, 1995, around 6 p.m., in the middle of rush hour, 5 crowded cars left Ulduz Station toward Nariman-Narimanov Station, located nearly 2 kilometers away. After moving just 200 meters, the subway stops and a black blanket of toxic smoke invades the cars. The electrical system that controls the doors fails to respond. Nearly 1,000 travelers are trapped. Inside, 80% of the materials are flammable, most of them synthetic. Many passengers die within minutes, poisoned by carbon monoxide. The others manage to smash the windows and flee down the tunnel, but many will be trapped amid the chaos. For a long time, the press and the locals spread the rumor that a bomb caused the damage, but it's never proven. The investigation concludes that the fire was started by a simple short circuit in an electrical device located at the back of car 4. The tragedy left 289 dead and more than 500 injured. It is the deadliest metro accident in history.
Three days later, the weight and the pain are agonizing.
Our bridges, our tunnels, our dams, they show to what extent we're capable of meeting the most ambitious construction challenges. But the disasters in our ranking prove that a lack of attention or a seemingly trivial failure can have tragic consequences. Today, new construction employs modern surveillance technology and is designed to meet increasingly stringent safety standards. But the thousands of existing structures throughout the world demand constant monitoring and meticulous maintenance to keep them safe. Still, no matter how hard we try or how vigilant we are, accidents will happen and materials will fail.